Hello everyone, Assalamu alaikum. I am Yasin Arafat. I am from 65A batch, Department of Tripoli, World University of Bangladesh. Welcome to my presentation. This presentation is made of on the basis of case study 2. In this case study, I will describe about problem 2. Problem 2 is here. This is the question of problem 2. The single line diagram of figure shows a generator connected through parallel transmission lines to a large metropolitan system considered as an infinite bus. The machine is delivering 1.0 per unit power and both the terminal voltage and the infinity bus voltage are 1.0 per unit. Numbers on the diagram indicate the values of reactances on the common system base. The transient reactance of the generator is 0.20 per unit as indicated. Determine the power angle equation for the given system. Operating conditions rule equal ABCD. Here x prime d equal 0.2 a, that means a, and here b and c is variable, and this variable have to exchange with my rule number. Here my rule number solution of this problem is given. My rule number is 4163, so here first digit is a equal 4 and second digit 1, that means b equal 1, third digit is 6, so c equal 6, fourth digit is 3, that means d equal 3. So there was j 0.1 b. I have exchanged this b with respect to 1, that's why there is j 0.11, and there was a, and I have changed a with this value of my rule number 4, that means here 0.24, and here was 0.4 c. I have exchanged my rule number code c equal 6. Here I have input this value of c. So we know the equation of power equal P max into sine del, where P max equal E1 prime modulus E2 prime by x. Here x is reactance given. Delivering power to the system equal 1.0 per unit. Terminal voltage equal 1.0 per unit. Infinite bus voltage equal 1.0 per unit. The transient reactances of the generator equal 0.24 per unit. Reactance of the transformer equal 0.11 per unit. Reactance of the transmission line equal 0.46 per unit. The reactance diagram of the system is shown in below. From the diagram of question, I have made this diagram. It is the diagram of reactance diagram of this system, and from this diagram we get the series reactance between the terminal voltage and the infinity bus is here 0.11 is connected of these two reactances, connected with of these two reactances, and these two reactances is connected in parallel with one another. That's why I have divided this value of 0.46 by 2 and with added with 0.11, and there I get this reactance x. And and therefore the 1.0 per unit power output of the generator is determined by V1 V2 modulus V1 modulus V2 by X into sine alpha equal 1.0, and 1. If I multiply 1.0 into 1.0, I will get 1.0, and if I transfer the 0.34 here, I will get sine alpha equal 0.34. Then alpha equal sine inverse 0.34 and alpha equal 19.876 degree, where V is the voltage of the infinite bus and alpha is the angle of the terminal voltage reactive to the infinite bus. So the terminal voltage is Vt equal 1.0 angle 19.876 degree. If I convert this polar form into rectangular form, I will get this equation 0.9404 into J 0.339 per unit. If you ask me how I have converted this rectangular equation, I will explain you. If you multiply this angle with respect to cos 19.876 is 0.9404 and sine 19.876 is 0.339. Here I get this equation by using this system, and the output current from the generator is now calculated as it is from this circuit. I get the basic equation from this circuit. I get this equation for finding the current, the output current of the generator. If I observe the circuit, obviously I get this equation of current, and here del 2, value of del 2 I got before by calculating 19.876 degree. I have input this value here, and this value have represented by rectangular form here, and these values rectangular form is 1, and by calculating this thing I get this value, and the transient internal voltage is then found to be E1 prime equal 0.9404 plus J 0.339 plus J to 0.24 into 0.997 into J 0.176. This value, this is the reactance value, and this is the value of current. If I multiply value of reactance and value of current, I will get voltage. So by adding these two voltages, I got this value. Hence the desired power angle equation. This is the equation. Here by using this equation, I can easily find out the power angle equation, and I have input this value 1.0682 into 1, value of x is 0.58, and E2 prime 1.0 and E1 prime 1.0682, and sine del I got 1.8417 sine del. So where del is the machine rotor angle with respect to the infinite bus. Thank you sir, and thank you all.